So we're going to cover simplify by factoring. So when we're factoring with trig function, just like how we did for converting to sine and cosine, applying the identities. When it comes to simplifying by factoring, what I mentioned in chapter 1, factoring involves division, but here we have a quadratic equation, x squared minus 7x plus 12. If I were to ask you to factor, you would write it in factor form, which would be x minus 3 and x minus 4. This would be the factors for this function, this quadratic function. So, in summation, when I'm asking you to simplify by factoring, all you're doing is just converting or breaking down this big function into smaller parts which we can work with when simplifying. So if I were to talk in terms of where you have sine, cosine, tangent, cosecant, cotangent, and cosecant, it's kind of hard to simplify if you don't break it down into smaller parts. Now, factoring is a method where you could break it down into smaller parts and it's manageable, you can work with it. So here, if I were to ask you to simplify x squared minus 7x plus 12, you wouldn't know how to do it. So, therefore, I would say simplify by factoring. You would factor this part, and you would break it down to x minus 3 and x minus 4. It's like, hey, maybe I could use x minus 3 for something, or hey, I could use x minus 4 for something else. So, that's the purpose of factoring. So make sure you have that, simplify by factoring is to break down a big function or a complex function into smaller parts so that we can work with smaller parts and continue simplifying. In our first example, we have sine of pi over 2 minus theta, then minus sine squared theta, cosine theta. So before we can actually get into any factoring, let's see if we could apply any identity, because this part right here, I don't think I could do anything when it comes to simplifying, but maybe I can apply an identity. In this case, we did cover this sine pi over 2 minus theta. So what I'm going to do, I'm going to apply the cofunction identity. So I'm going to write below here, cofunction identity. So the cofunction identity for sine, so sine of pi over 2 minus theta is equal to cosine theta. So I'm going to apply that to make this whole function, this whole equation simpler. So sine pi over 2 minus theta is the same thing as cosine, so I'm going to rewrite it just as cosine theta. And then I'm going to bring down everything else, so minus sine square theta cosine theta. Okay. So all I did was I just changed sine pi over 2 minus theta into cosine theta because of the cofunction identity. Now, here I would factor out the common factor. So here's the first part and here's the second part. They both have cosine. So here, I'm just simply factoring out. I'm going to write right here, I'm factoring. Factoring cosine theta because they both have cosine. So when I'm factoring, again, it's involved with division. So I'm going to divide both parts by cosine theta. Now, it doesn't go away. since I mentioned, and I'm emphasizing on factoring, my common factor that I'm dividing by will be on the outside. So cosine theta, and then parenthesis. So I'm looking at this one. Cosine theta divided by cosine theta will be 1. Sine squared theta cosine theta divided by cosine theta will be simply minus sine squared theta. So I factor and broke it down into simpler parts. I still have that cosine theta, which I divide by, or I factor out, and then I have 1 minus sine squared theta. Hey, 1 minus sine squared theta, that looks familiar. Let's see. It looks similar to the Pythagorean identity, so I'm going to write right here. Where it's sine squared theta plus cosine squared theta equal to 1. So if I were to subtract by sine squared theta on both sides, then I would have cosine squared theta equal to 1 minus sine squared theta. So this 1 minus sine squared theta is exactly the same as this one over here, 1 minus sine squared theta. So what I can do, I can switch this part and have it change into cosine squared theta. So that's what I'm going to do. So I'm going to have the cosine on the outside, and then instead of 1 minus sine squared theta, I'm going to switch it out with cosine squared theta, because that's what's it equal to. Okay, so finish applying the Pythagorean identity, and the only thing I have left is cosine theta times cosine squared theta, which I can multiply. Cosine theta times cosine squared theta will become cosine to the third theta. So that is our final answer. So in review, given the example sine pi over 2 minus theta minus sine squared theta cosine theta, first I applied the cofunction identity to change this into an easier part. So sine pi over 2 minus theta, using the cofunction identity, I changed it to cosine theta, which it led to cosine theta minus sine squared theta cosine theta. Now, as I take another look, I notice that these two parts, they both have cosine, so I'm going to factor out cosine theta. So when I'm factoring, I divide both parts by cosine, but I have it on the outside of the parenthesis. When I divide both sides by cosine, I'm left with 1 minus sine squared theta. Then I notice that I could use the Pythagorean identity, which I've shown here. Cosine squared theta is equal to 1 minus sine squared theta. So I simply switch those two. That led me to have cosine theta times cosine squared theta. And then the final answer was cosine to the third theta. In this example, we have sine pi over 2 minus theta times cosecant squared theta minus cosine theta. Alright, so just like the last example, I'm going to simplify using the identity. I'm going to switch out sine pi over 2 minus theta with cosine theta using the cofunction identity. So this, switching out, and that's going to become cosine theta, and then everything else will stay the same. So we have cosecant squared theta minus cosine theta. Now, just like the last part, the last example, going to factor out, they both have cosine, so I'm going to divide both parts by cosine. Again, it does not go away. I'm just dividing, so cosine will be on the outside, the common factor. When I divide this, I'm left with cosecant square theta, and then minus cosine theta divided by cosine theta will be minus 1. So again, my common factor that I divide by, or I factor out, is on the outside of the parenthesis. Now here, I notice I have a cosecant square theta and a minus 1. So let's see, is there an identity I can apply for that one? Which there is. I'm going to write it out, the Pythagorean identity. So the Pythagorean identity that I'm going to refer to is cotangent squared theta plus 1 equal cosecant squared theta. Now, if I want to convert this similar to this, meaning that you see how there's a 1 and cosecant squared theta together? So I need to get this 1 to be with this cosecant square. So I'm going to subtract 1 to cancel out from the left side, and then subtract 1 on the right side. So it will be cotangent squared theta equal cosecant squared theta minus 1. So here, cosecant squared theta minus 1 is the same thing over here. So it is equal to cotangent squared theta. So what I'm going to do is I'm going to switch cosecant squared theta minus 1 with cotangent squared theta. So I'm still going to have cosine theta times cotangent squared theta. Now when you have something like that, I can just drop the parenthesis and then it will simplify into cosine squared theta cotangent squared theta. And that's where you can stop. So I would box this up. And that would be your final answer. Now, if you had a question where it says simplify in terms of sine and cosine, so let me make some room. I'm going to erase this. If it asks you simplify by factoring and in terms of sine and cosine, so I'm going to write the question. So in terms of sine and cosine, so if you're simplifying by factoring and then simplify into terms of sine and cosine, so that means that here I will not stop, I will just continue. So I'm going to write right here cosine theta cotangent square theta. Alright, so it means that to have your final answer where it's only, you either have just sine, or you either have cosine, or you have sine and cosine. But in this case, we have a cotangent, so I can't stop there. What I can do is I can apply the quotient identity to cotangent, because quotient identity gives you sine and cosine. So it will be cosine theta. Now for cotangent squared theta, it will be cosine squared theta over sine square theta. And just like a whole number for the cosine, I'm just simply going to multiply to the top. So on the top, cosine theta times cosine squared theta will become cosine cubed, or to the third, theta, and then sine squared theta. So if you see a question where it says simplify by factoring and then in terms of sine and cosine, you would continue, and then this will be your final answer. So just a little practice of converting, simplifying, rewriting in sine and cosine. But if it just say simplify by factoring, you would stop here. But if the question is longer, where it's asking you in terms of sine and cosine, you would continue, which I did, and then rewrote it, and my final is in cosine to the third theta, sine squared theta. So that's all you have to do. In this example, we have negative sine theta cosecant square of pi over 2 minus theta, and then plus sine theta. So when we're going to simplify this, I would usually work with this one first here. The cosecant square of pi over 2 minus theta, now it is not exactly the same because it has a square, but it has that pi over 2 minus theta, which means, could I apply the cofunction identity? So again, let me write the name, cofunction. So in this case, I could. So what I'm going to do is I'm going to rewrite it. So the first part is negative sine theta. Now for the one that I underlined, the cosecant squared theta, cosecant square of pi over 2 minus theta, I'm going to rewrite it as, according to the cofunction identity, it will be secant square theta, and then plus sine theta. Alright, so now we have negative sine theta, secant square theta, plus sine theta. I notice that in these two parts, the first one, negative sine theta, secant square theta, and then in the second part, sine theta, they both have sine. So what I'm going to do, I'm going to factor out the sine. Now, I usually look at the first sign, starting from my left side. I notice that it's negative. So, in the previous example, I divided by a positive sign and a positive cosine. In this example, since the first sign from the left side is negative, I'm going to divide, or in other words, factor out negative sine theta So I'm going to factor out negative sine theta. It's still going to be on the outside of the parentheses, so negative. So negative sine theta, parenthesis. So when I factor out negative sine theta secant square theta by negative sine theta, it will be secant square theta. And then here, positive sine theta divided by negative sine theta will be minus 1. So we factor into simpler parts. Taking another look at this, I see a secant square theta and a minus 1. So that's a square and it has a minus 1. So I gotta think, does this involve Pythagorean identity? Going back, it does. So if I were to talk about the Pythagorean identity, so the one that has secant square and 1 would be the tangent squared theta plus 1 equal secant square theta. So that's the Pythagorean identity that we're going to use. Now, here I have secant squared theta with the minus 1 but the 1 and the secant square theta are on separate side of the equal sign. So what I'm going to do, I'm going to cancel out this 1 by subtracting 1 on the left side, subtracting 1 on the right side. So tangent squared theta will equal to secant squared theta minus 1. So this part is exactly the same as that part. So what I'm going to do, switch out secant squared theta minus 1 with tangent squared theta. So I'm going to write out negative sine theta, and then switch out with tangent square theta. And then when you have something like this, then you can just drop the parenthesis, which will be negative sine theta tangent square theta. So if it simply asks you simplify factoring, then this will be your final answer. Now, in the last example, I show you a part where if it asks you to simplify in terms of sine and cosine, I would continue from here. So I'm going to write it right here. So negative sine theta tangent square theta. So if it asks you to simplify in terms of sine and cosine, I would use the quotient identity on tangent, because the quotient identity will give you sine and cosine. So negative sine theta. Now for tangent squared theta, it will be sine squared theta over cosine squared theta. And then when I'm multiplying, the negative sine theta is like a whole number, so I'm simply going to multiply to the numerator. So negative sine theta times sine squared theta will become negative out here, so sine to the third theta over cosine squared theta. There's nothing I can do to simplify, so that will be your final answer. This will be for if it asks you to simplify in terms of sine and cosine. The one on the left, negative sine theta tangent squared theta, that will be your answer for simplifying by factoring.